This is Senior Algebra Section 4.3, Solving Linear Systems by Elimination. So today, we're taking a look at another way to solve systems. So we've looked at graphing, we've looked at substitution, and now we're looking at elimination. So first thing when we do elimination, we're trying to eliminate one of the x's or y's. So when we solve, we have a problem in that we have an x and a y in one equation. We can't really solve for one of the variables. So we're going to try to eliminate it. So the first thing we're going to do, write it in standard form. Get your x's and y's on one side, get your constant on the other. And we want to get it so that either the x's or the y's are opposites. So when we think about adding equations here, it's no different than what you've done before in solving equations. So if I look and I was given 3x plus 5 equals 20 here, I would add the equation negative 5 to both sides. Now I could pick any numbers, but of course we pick negative 5 so that they cancel out. So I add down 3x and 0 is 3x. And 20 and 5 is 15, and we go from there. And the 5s will cancel out. Well, we're going to do the same thing. So on the right, I have 2x plus 3y equals 10, and negative 2x plus y equals any number we want. We'll pick 14. When I look at the x's, I have a 2x and I have a negative 2x. When I add them together, they will eliminate, hence the elimination. So that's what we're looking to do here. So the first thing, I'm going to write everything in standard form. Get your x's and y's on one side, get your constants on the other. So for us, that means move the 2y over. I have 22 equals 4x minus 2y. I'm going to move the 2y to the others from the other side as well, and I'm going to get 10x minus 2y. So at this point, I'm just going to rewrite my equations here, give myself a little bit of room. So when I rewrite them, I'm going to write 4x minus 2y equals 22. And 10x minus 2y equals 52. So I'm lining up my x's. X's, y's equal your number here. So I'm going to look. I look at my x's. My x's aren't the same, but my y's are the same. So I have a negative 2y and a negative 2y. Well, the problem is if I add those together, I don't get rid of the y's here. So I'm going to have to do something to the equation. And in this case, I'm going to multiply one of the equations by negative 1. That will give me on the top a positive 2y and on the bottom a negative 2y, and those, when we add them together, will cancel out. Keys in this, you have to remember to distribute to the whole thing, to the left side and the right side. What I do to the left side, I have to do the right side. So now, I've lined everything up. I've got it. Now I'm going to add down. When I add down, the 2y, the negative 2y cancel out. I'm left with 6x equals 30. And from here, we just solve it like we usually would. Divide by 6, x equals 5. So at this point, that's one of the solutions here, or one part of the solution, I should say, because we have to figure out what y is. Remember, we needed a point, an x and a y here. So I'm going to plug it into one of the equations. Which one? Doesn't matter. I'm going to pick the first one here. But again, you can pick the second one just as easily. So I have 2y plus 22 and that equals 4 times my x, and my x in this case is 5. I'm going to solve it, move the 22 over. And I get 2y equals negative 2. When I divide each side by 2, I get y is negative 1. Now if I plugged it into the other equation, I would get the same thing. And I could plug both the numbers in to each equation and check to see if it is true, if it works in both of them. My final thing, I do want to write it as an ordered pair, and that's my final solution, 5, -1. So in example 2, the same thing. We're going to line up our x's. X's, y's equal your number. So I get 2x plus y equals 4. And I don't need to do anything to the other one, so I'm just going to write it right below it. At this point, I look at my coefficients. I look at the x's, I look at the y's. My x's here, I have a 5 and a 2. And I look...
Michaela's Rester, Emily Malone, you have something in the main office to pick up at this time. Thank you.
And I look at this and I go, well, can I multiply one of the equations by something, some integer, that will get rid of it? Well, I look at my y's, and if I multiplied the bottom by a -3, that would give me the top, which is 3y, so that would cancel out. Top, I'm not going to change, 5x plus 3y equals 10. The bottom, when I distribute, multiply both sides, I get -6x minus 3y equals -12. So the y's, 3y and a -3y, they are going to cancel out. They're going to be eliminated. When I add down, I get -1x equals -2. So when I divide by -1, x is 2. I'm going to plug it into one of the equations to figure out what my y is. That's when I'm going to start with the second equation. Again, it doesn't matter. I do want to plug them into the original equations. That way, any mistakes I made will come out. So I get 3y equals 0. And of course, I still have to divide by 3. And 0 divided by 3 is just 0. I could just as easily have done it with the first equation. And we should get the same answer. We should get 0. So when I plug it in, 2 and 2 is 4. I get 0 equals -y. When I divide by -1, I get y is 0. Obviously, you only have to do it for one of the equations, but I was just showing you, yeah, you get the same thing. So what's my final answer? I'm going to write it as an ordered pair, 2, 0. The last equation, or the last system to solve here. So in this one, the first one is all in the standard form. X's, y's equal your number. Second one, I'm going to move the 9y over. So I have 3x plus 9y equals 2. I'm going to rewrite them. And again, I'm going to write them in vertical order here and line things up. So when I write this, now I'm going to look and try to eliminate my x's or y's. First thing I look at is, can I multiply one of the equations to get the same variable except an opposite in the other one? So if I look, I have a 2 and a 3 for the x's. And a 6 and a 9 for the y's here. So can I multiply 2 by some integer? No. So I'm going to have to multiply both of them. So I'm going to look to eliminate my x's. I have a 2 and a 3. So I can multiply them by each other, and I can say, well, -3 and 2 is -6. 2 and 3 is 6x. So I kind of use that idea that I can just multiply them by each other to get the same thing. When I do that, I look and I look at my x's. My x's cancel out, which isn't surprising, but my y's also cancel out. So I'm left with 0 on the left side, and I'm left with -32 on the right side. So 0 equals -32. Is that true? No. So what does that mean? No solution. Obviously, if we got a true statement, 0 equals 0, it would be infinitely many solutions, like the ones that we've looked at with graphing and substitution.